This is our setup for finding the resonant frequency using a parallel LCR circuit by drawing the frequency response curve. This is a self-sufficient kit which comes with an audio oscillator having a frequency range of 10 kilohertz. There is an amplitude control, and the amplitude can be varied from 0 to 10 volt peak to peak. There is a resistance bank having 4 different types of resistance, and one terminal is provided to attach any resistance of your choice. There's an inductance bank having 3 different values of inductances, that is 100 millihenry, 150 millihenry and 200 millihenry respectively. There is also a capacitance bank having 4 different kind of capacitors, and 2 terminals are provided to attach any capacitor of your choice. There are 3 meters over here. On the left hand side we have a voltmeter, in the middle we have a milliammeter, and on the right hand side we have a frequency counter. This kit comes with a detailed manual which contains detailed procedures, graphs, experimental data and the circuit diagram, and it also has an adequate number of cords which are required to connect the circuit. Now we will make the circuit and see what we get as readings. You will find a detailed circuit diagram given in the manual. Following this circuit diagram, we'll now make the connections. We are connecting the output of the audio oscillator to the input of the onboard circuit. This is the parallel LCR circuit diagram where the audio oscillator, the milliammeter, the resistance and the capacitance are connected in series, and the L is connected in parallel. We are connecting the series circuit first. So the audio oscillator, the resistance, the milliammeter and the capacitor is being connected in series. After this, the inductance will be connected in parallel. We'll be measuring the input voltage, and the voltmeter has been connected in parallel with the input. This is our final circuit connection. Now we will switch on the circuit and take the measurements, readings. So I've switched on the circuit. We are pressing the multiplier 1K, and we are now setting the input voltage at 3 volt. You can see in the voltmeter here, it's set at 3 volt. The current here is 9.25 milliampere and the frequency is 400 hertz. So we'll change the frequency and the current will start to decrease initially, and at the resonant frequency it will be at the minimum value and then it will start to increase. Still decreasing. We are increasing the frequency. The input voltage is almost constant. So it started to increase, so we'll go back and find out the value where it is minimum. So this is our minimum value, 0.87 milliampere, and which corresponds to the resonant frequency 3.5 kilohertz. So this is our resonant frequency. If we do a theoretical calculation for the values of 220 ohms, 100 millihenry and 0.02 microfarad, then we will find the resonant frequency to be 3.4 kilohertz. So we are getting a very good value, which is almost equal to the theoretical calculation. We will now try out for another combination. Here we have connected R as 470 ohms Inductor is 150 millihenry and the capacitor value is 0.03 microfarad. So we have set the input voltage at 3 volt. The current is 6.27 and we have started to increase the frequency. Current starts to decrease. We will find the point where it is minimum. So if we theoretically calculate it, it comes to 2.4 kilohertz, and practically also we are obtaining 2.35 kilohertz, which is very near to the theoretical value. So this concludes our experiment. You can try for any other combination of LC and R and you can find out what you're getting as the resonant frequency. We now will plot the frequency resonance curve. Here there are a lot of combinations given and the resonant frequency has already been calculated over here. If we plot the curve, for the parallel LCR circuit, it will be like this. Sample data has also been given for the parallel LCR circuit. So this manual is very detailed and we'll get all the necessary details from there. This concludes our experiment for finding out the resonant frequency using a parallel LCR circuit. Thank you.